Hello students, welcome to Akash Live. I'm your mathematics faculty and today we're going to discuss the quick solutions of AIATS, that is All India Akash Test Series for JEE Advanced 2019, test number 1A paper 1, and the code is code C and code D. Okay, so this test was held on 4th of November 2018 and let us now start the solution discussion of this particular paper. So let us begin with question number 37, that is the first question of mathematics section. This says that if iota is under root of -1, which is a usual notation, then which of the following options is or are incorrect? So you have to choose incorrect options. So we'll have to discuss all the options. Let us discuss option number A. The equations x bar 20 equal to 1 and x bar 10 equal to iota have 10 common roots. Option B also talks about the same two equations. So x bar 20 equal to 1 and x bar 10 equal to iota. Students, the roots of x bar 20 equal to 1 are distributed on the unit circle at 20 equal intervals. That means the difference of the angle is equal to 18 degrees. Let us talk about x bar 10 equal to iota. This can be written as x bar 10 upon iota equal to 1, and this can be written as x bar 10 upon e raised to the power iota pi by 2 equal to 1, and which is further equal to x upon e raised to the power iota pi by 20 whole raised to the power 10 equal to 1. The roots of this equation, something raised to the power 10 equal to 1, are distributed along the unit circle at 10 equal points starting from 1, 0. So if I have the roots of x as, so x upon e to the power iota pi by 20 के roots 10 equal points पे distributed हैं. When I calculate the value of x, I will multiply e to the power iota pi by 20 with each root, and multiplying e to the power iota pi by 20 with each root means that I am rotating all the roots by 9 degree because pi by 20 is 9 degree. So initially x bar 20 equal to 1 and x bar 10 upon e to the power iota pi by 20 raised to the power 10 had 10 common roots. The difference of angle here is 18 degree. And this has been rotated by 9 degree. So we can definitely say that they have now 0 root in common. Okay. So both the option A and option B are correct. Because option A says it has 10 common root. Wrong. Option B says that it has 5 common root. Again wrong. So this is a very interesting question based on rotation formula. Okay. Now let us talk about option number C. Equation x bar 40 equal to -1 and x bar 20 equal to iota have 20 common roots. So x bar 40 plus 1 equal to 0 can be factorized as the roots of -1 are iota and minus iota. So x bar 20 plus iota and x bar 20 minus iota. That means x bar 20 equal to iota is a subset of the solution of the first equation. That means these two equations have 20 common roots. Option number C is wrong. Why it is wrong? Because it is correct. And we have to choose the incorrect ones. Option number D. Again, when I talk about x bar 60 plus iota. So applying a cube minus b cube, x bar 60 minus iota cube it is written. So x minus x bar 20 minus iota, first bracket, x bar 40 plus iota x bar 20 plus iota square, that is -1 equal to 0. Again we can see that x bar 40 plus iota x bar 20 -1 equal to 0 is given in option number D. That means this equation is a subset of first equation. Definitely they will have 40 common roots. Option number D is correct. That is why it will not be my answer. Final answer for this particular question is option number A and option number B. Okay. Let us move forward to 38. Question number 38 says that let a function fx equal to sin square x plus cos bar 4x plus sin bar 6x from x belongs to 0 to 2 pi. I have to find the solutions of this particular function with some constant lines running parallel to x-axis. Okay. So let us first of all analyze fx. Fx is sin square x plus cos power 4x plus sin power 6x. Students, I just have the interval 0 to 2 pi with me. So let us directly differentiate it and find the points of maxima and minima. So f dash x will be equal to 2 sin square x over here, 2 sin x into cos x plus 4 cos cube x into minus sin x plus 6 sin power 5x cos x. That means let us take 2 sin x cos x into 1 minus 2 cos square x plus 3 sin power 4x. Replacing cos square x as 1 minus sin square x, I will get 2 sin x cos x into 3 sin power 4x plus 2 sin square x plus 1 minus 2. So it will be minus 1. Ultimately, it comes out as 2 sin x cos x into sin square x plus 1 into 3 sin square x minus 1. You can factorize the square bracket over there. Okay. This is f dash x. So f dash x is equal to 0 when 3 possibilities: sin x 0, cos x 0, sin square x equal to 1 by 3. Okay, so let us try to plot the graph of this particular function by using increasing decreasing nature. Okay, so we have the interval given is 0 to 2 pi. Okay, fx is sin square x plus cos power 4x, sin square x plus cos power 4x plus sin power 6x. F of 0 is 1. So this point is 1. We can directly see that the maximum value of this particular function will be 2 because there are 3 ratios. Okay. So sin x, when it is equal to 1, this is 1 plus 0 plus 1. Maximum value is directly 2. Okay. When we just start moving ahead of 0, sin x is positive, cos x is positive, sin square x plus 1 is always positive. This quantity will be negative. That means it is a decreasing function just after 0. Sin square x equal to 1 by 3. Sin square x equal to 1 by 3 is the critical point that will be encountered. Then cos x equal to 0. Then sin x equal to 0. So I will have to plot all the critical points carefully on the x-axis. Let us have them. One is pi by 2 because cos x will be 0. Then one is pi, sin x is 0. 0 is obviously a critical point. Then 3 pi by 2. And then at last 2 pi. These are 4 critical points corresponding to these two equations. Sin square x equal to 1 by 3. This will happen 4 times in 0 to 2 pi, once in each quadrant. So let us say there is one particular angle alpha. Here one more critical point beta. Here one more critical point gamma. Here one more critical point delta. Okay. So every single quadrant has this critical point sin square x equal to 1 by 3. This point is obviously origin. So now we are all set to make the graph of this particular function. Okay. As we have discussed, it will be a decreasing graph just after 0 and it will attain a minimum value at the first critical point. So let us say this is the first critical point. 0 is also critical point. At pi by 2 and 3 pi by 2, it will touch 2 because sin x is 1. This is at pi by 2. At beta, again, the value will be same because sin square x equal to 1 by 3 will give one particular value to this particular function. So again, we have to drop down till here. Same value. Now it will go up. At x equal to pi, the value is 0 plus 1 plus 0. So this value is 1. Again will go down. Critical point, change of increasing decreasing behavior. Gamma, same value as alpha. 3 pi by 2, maximum value 2. At each critical point, it will go from increasing to decreasing or decreasing to increasing. So again, decreasing graph, the value will be the minimum value, and then again increasing. At 2 pi, the value is 1. So we have to discover this particular value now. The value which is obtained at 4 critical points corresponding to sine square x equal to 1 by 3. This particular value is 22 upon 27. You can simply substitute sine square x as 1 by 3. Cos pi 4x can be directly obtained. Now we are finally ready to answer all the 4 options. Option number 1, fx equal to 7 upon 9. 7 upon 9, obviously it is a value less than 22 by 7. So definitely it has no solution. Option A is correct. Option B, fx equal to 8 by 9 has 8 solutions. Slightly greater than 22 by 27. 1, 2, 3, 4, 5, 6, 7 and 8. 8 solutions for fx equal to 8 by 9. Very correct. Fx equal to 1 has 7 solutions. Fx equal to 1. 1 solution, 2 solution, 3 solution, 4 solution, 5 solution, 6 solutions, 7 solutions. The interval is 0 to 2 pi closed. Correct. Option number D, fx equal to 3 by 2 has 6 solutions. 3 by 2, exact midpoint. It has 4 solutions. Option number D is wrong. Final answer of question number 38 is option number A, option number B and option number C. ABC. Okay. Let us move on to 39. Okay. This is a very, very interesting question of range of a particular function in trigonometry. Okay. Let us move on to 39 now. Again, this question is based on trigonometry. Let the minimum value of the expression fx equal to 2 raised to the power 1 minus sine square x minus sine x plus 2 whole raised to the power 1 minus cos square x minus cos x be m. Then I have to find out m. Fx equal to m has how many solutions? And then the last equation, general solution of fx equal to m is what? Okay. Let us talk about fx. In first sight of the question, you will replace 1 minus sine square x by cos square x. 2 power cos square x. Minus sine x. Okay. Plus, again in the first sight, 1 minus cos square x as sine square x. Minus cos x. Students, what are we going to do? We are going to apply AM-GM inequality. Okay. 2 raised to the power cos x. You can very well see that 2 raised to the power anything divided by 2 raised to the power anything. Both numerator denominator positive. First number is positive, second number is positive. We can apply AM-GM inequality between these two quantities. So applying AM-GM, inequality. Students, you must know that AM is sum of two numbers divided by 2. Fx is sum of two numbers. So AM is fx upon 2. Greater than equal to under root of product of two numbers. I will have 2 power cos square x divided by 2 power cos x. Now, the product of two numbers will be 2 power cos square x into 2 power sin square x upon 2 power sin x into 2 power cos x. Fx is greater than equal to 2 times 2 power cos square x plus sin square x, that is 1. 2 power 1 upon 2 power sin x plus cos x. Students, I need to find the minimum value. Here is the key. Fx will be minimum when the denominator will be maximum. Sin x plus cos x takes the maximum value root 2. The value of m will come out to be 2 under root of 2 upon 2 raised to the power root 2. Okay. This is 2 into root 2. So 2 raised to power 3 by 2. 2 raised to power minus 1 by root 2. This is 2 raised to power root 2 whole under root. So this is 2 raised to power 1 by root 2 in the denominator minus 1 by root 2. In the interval 0 to 2 pi, sin x plus cos x take its maximum value only once. That means this function will take its minimum value only once. Option number C is correct, B is wrong, A is also wrong. The general solution of fx equal to m is x equal to n pi plus pi by 4. It is same as the general solution of sin x plus cos x is equal to root 2, which is 2n pi plus pi by 4. This is also wrong. So this is a multiple choice correct question with a single answer, only and only option C. Okay, let us move forward to question number 40. So next up we have question number 40. It says that if theta is a parameter lying in the interval 0 to pi by 2, that means the first quadrant, and x1 sin theta plus x2 cos theta plus x3 tan theta plus x4 cot theta plus x5 cosecant theta whole raised to power 10 is equal to sigma 10 factorial upon a factorial, b factorial, c factorial, d factorial, e factorial into x1 sin theta raised to power a, x2 cos theta raised to power b, x3 tan theta raised to power c, x4 cot theta raised to power d, x5 cosecant theta raised to power e, for all theta belongs to 0 to pi by 2, where it is very obvious that a plus b plus c plus d plus e is equal to 10. Then I need to calculate the number of terms independent of theta. All the four options are talking about the same thing, that we need to target is independent of theta terms. Okay, so now let us quickly analyze the given multinomial expression. If I write down the general term and I write down the powers of sin theta and cos theta in the general term, I will have TR as, it will be 10 factorial upon a factorial, b factorial, c factorial, d factorial, e factorial. Carefully see, we will have x1 raised to power a, x2 raised to power b, x3 raised to power c, x4 raised to power d, and x5 raised to the power e. Obviously, I am not concerned with the factorial terms and the x1, x2, x3 terms. I am concerned with sin theta, cos theta, tan theta terms. I'll have sin theta raised to power a, cos theta raised to power b, tan theta raised to power c, cot theta raised to the power d, and finally cosecant theta raised to the power e. I need the terms which are independent of theta. Let us convert all the trigonometric ratios in the terms of sin theta and cos theta. So now I am going to write only the terms containing theta. The power of sin theta will be a plus c minus d minus e. So this particular term has to be 0. Power of cos theta will be b minus c plus d. Okay. Now we have three relations governing the values of a, b, c, d, e. The first relation is a plus b plus c plus d plus e equal to 10. That is given in the problem. Second relation, power of sin theta should be 0 because I need the term independent of theta. So a plus c is equal to d plus e. Further, power of cos theta is 0 because I need term independent of theta. B plus d is equal to c. Solving these three equations, I will get the value of c, d and e in terms of a and b. So c value will be 5 minus a minus b by 2. The value of d will come out to be equal to 5 minus a minus 3b by 2. And then obviously we can see that, and you can easily solve the value of e. It will come out to be a plus b. Okay. Now let us make the table for a, b, c, d, e values using these three relations. Okay, so let us write down the relations. C is equal to 5 minus a minus b by 2. D is equal to 5 minus a minus 3b by 2. E is equal to a plus b. And ultimately we also need a plus b plus c plus d plus e is equal to 10. So obviously we'll have to write down all the possibilities. A, B, C, D, E. We can clearly see that, students, B has to be a multiple of 2 because A, B, C, D, E all are either 0 or they are natural numbers. So that means B has to be a multiple of 2. Let us take first of all B equal to 0. So if B equal to 0, I have C is equal to D is equal to 5 minus A and A is equal to E. Okay, from the third relation. So let us put A as 1, E as 1. So C and D will be 4, 4. Let us take B 0 again. Put A as 2, E as 2. They will be 3, 3. Put B as 0, E and A as 3, 3. They will be 2, 2. Again B0, 4, 4, 1, 1. Again B0, 5, 5, 0, 0. Again B0, these two are 5 or these two are 0. Because we can see that A plus C is 5, A plus D is also 5 and A is equal to E. These are total 6 possibilities in correspond to B equal to 0. Okay, so let us draw a small line here and write down the further possibilities. Let us put B equal to 2. So for B equal to 2, this relation will be changed. Let us write it again. For B equal to 2, C will be 4 minus A, D will be 2 minus A, and E will be A plus 2. So let us put A as 1. So let us take A as 0. So if A is 0, I have E as 2, D as 2, and C as 4. Obviously the total is 10. Let us put this as 2 again. Put A as 1. So E is 3, D will be 1, and C will be 3. So 3 plus 1, 4 plus 3, 7 plus 3, 10 again. Again 2. So let us take over here A as 2. So D will be 0, C will be 2, E will be 4. So 2, 2, 2, 6 and 4, 10, again correct. Now let us explore the further possibilities. Okay, so further taking the possibilities, let us put B as 4. Okay, so putting B as 4, I will get C as 5 minus 2, 3 minus A. D will be minus A minus 1. That means we cannot have further possibilities here because A is either a natural number or 0. D is also the same. So D plus A cannot be minus 1. That is wrong. Okay. So that means we end up with the possibilities here. There is no further possibility of any of the cases for A, B, C, D, E. Total we have 9 cases. Let us see the question now and the option number 1. Correct? If B is equal to 2, there are 3 terms in the given expansion which are independent of theta. Very correct. 1, 2, 3 terms independent of theta for which B is equal to 2. Correct. B equal to 3, no possibility. Wrong option because they write that there is only one term. Obviously, B cannot be equal to 3 because it has to be even. That we concluded on the second page of the solution. Okay. Further, if E is equal to D, there is only one term which is independent of theta. Where is E is equal to D? Let us check. One term here and there is no further term where E is equal to D. So that means option number 4 is also correct. Final answer of the question comes out to be ABD. Okay. Let us move on to question number 41. Question number 41 talks about cubic equation and it is a very simple question based on only one fact. Roots of an equation satisfy the equation. Let alpha, beta, gamma be the roots of the equation x cube minus x square minus 2x plus 1 equal to 0. Then we have to find out alpha, beta, gamma are also the roots of equation. Then alpha square plus beta square plus gamma square equal to 5. These two options we can easily solve. So let us solve them. X cube minus x square minus 2x plus 1 equal to 0 is the equation which has the roots alpha, beta, gamma. That means alpha cube minus alpha square minus 2 alpha plus 1 equal to 0. Same equations can be written for beta and gamma. What is alpha square plus 2 alpha minus 1? It is equal to alpha cube. See carefully. I have taken the 3 terms to the right and this is equal to alpha cube. So B option, it is alpha cube, beta cube, gamma cube. Because same relation holds for beta and gamma. Alpha, beta, gamma whole cube. What is the product of roots in this particular equation? It is minus plus minus minus 1 whole cube and that is minus 1 again. Which means that option number B is wrong. Okay. The answer is minus 1. Let us talk about option number D. Alpha square plus beta square plus gamma square. We have a standard identity. Alpha plus beta plus gamma whole square minus 2 times alpha beta plus beta gamma plus alpha gamma. What is alpha plus beta plus gamma in this equation? The answer is 1. Alpha beta into beta gamma plus alpha gamma minus 2. So the answer is 5, which means D option is correct. Now we are required to simplify two biquadratic equations. x power 4 minus 3x square minus x plus 1 and x power 4 minus 3x cube plus 5x minus 2. Let us try them. X power 4 minus 3x square minus x plus 1. I have to check whether alpha is a root or not. Okay. I know that alpha cube minus alpha square minus 2 alpha plus 1 is equal to 0 because alpha is the root of given cubic equation. What is the value of alpha cube from here? Alpha square plus 2 alpha minus 1. Multiply by alpha. Alpha power 4 equal to alpha cube plus 2 alpha square minus alpha. Again put the value of alpha cube. Alpha square plus 2 alpha minus 1 plus 2 alpha square minus alpha. This is 3 alpha square plus alpha minus 1. This is alpha power 4. So alpha power 4 minus 3 alpha square minus alpha plus 1 is equal to 0, which means that alpha is a root of this particular equation. A very well framed question. Okay. Option number A is correct. Similarly, let us check option number C. X power 4 minus 3x cube plus 5x minus 2. This is option number A and this is option number C. Starting from the given equation, alpha cube minus alpha square minus 2 alpha plus 1 equals 0. So let us multiply this equation by alpha. Alpha power 4 minus alpha cube minus 2 alpha square plus alpha equals 0. You can see that in this equation I have no x square term. So let us substitute alpha square from the second equation, that is this equation. Alpha power 4 minus alpha cube minus 2 into, what is alpha square? Alpha cube minus 2 alpha plus 1 plus alpha equal to 0. Ultimately I have alpha power 4 minus 3 alpha cube plus 5 alpha minus 2 equal to 0, which means that alpha is a root of this equation. Okay. Very well connected question again. Option number C is also correct. So final answer rests as ACD. Okay. Let us move on to last question of this section now. Okay. Talking about question number 42, it says that for the system of equations x plus y plus z equal to 1, x plus 2y plus 4z equal to k, x plus 4y plus 10z equal to k square, where k is a parameter, it is consistent and inconsistent we have to calculate. Okay. So let us quickly calculate delta, which is 1, 1, 1, 1, 2, 4 and 1, 4, 10. The value is expanding along row 1, 6, 20 minus 16, 4 minus 1 into 6 plus 1 into 2. That means delta equal to 0. Delta equal to 0, it means it will either have no solution or have infinite solution. Option number D goes wrong straight away. Delta x. Replace the coefficients of x by the constant terms. 1 k k square, 1 2 4, 1 4 10. Let us solve it equal to 0 just in order to get infinite solutions. You will get k square minus 3k plus 2 equal to 0, k equal to 1 or k equal to 2. Delta x is 0 for k equal to 1 or k equal to 2. So you can cross check that delta y and delta z both will go 0 for these two values of k. Okay, k equal to 1 and k equal to 2. It is consistent for only two real values of k. Consistent means the equation has a solution. Okay, it cannot have unique solution. So infinite solution means consistent. There are two values of k for which the solution is, for which the system of equation is consistent. Option number A is wrong. It is inconsistent for infinitely many values of k. Very true, because if you take any value of k except 1 and 2, this particular system of equations will give you no solution. Option number B is correct. When k equal to 1, we have to represent the solution in the general format in single variable. So let us do it. X plus y plus z equal to 1. Let z be lambda. So x plus y is 1 minus lambda. Second equation. X plus 2y plus 4z equal to 1. because k is 1. You have x plus 2y as 1 minus 4 lambda. Subtract these two equations. Minus y equal to 3 lambda, y equal to minus 3 lambda, and also get the solution for z, x, which is 1 plus 2 lambda. So z equal lambda, y equal minus 3 lambda, x equals 1 plus 2 lambda or 2 lambda plus 1, which is written over here. Absolutely correct. Option number A, B, C are the correct choices for this particular question. This section is over. Now we will move on to next section that contains integer type questions.